Here we have an operator and an operand. In infix notation, the operator is in between the operands. Take, for example, this equation. To solve it, we'll use the order of operations. Starting with parentheses, 2 plus 5 is 7, times 4 is 28, divided by 2 is 14. So yeah, infix is basically algebraic notation from school. Prefix notation, also known as Polish notation, is a mathematical notation where the operator is written before the operands. Here, expressions are not ambiguous and do not require parentheses or operator precedence. To solve this, we'll first move the innermost operator in between the two operands. This gives us division, 1 plus 8, and then 9. If we evaluate this, we get division, 9, and 9. Next, we move the next innermost operator in between our newer numbers, which gives us 9 over 9, which is 1. So this equation up here evaluates to 1. To solve this new example, we'll first look at the two innermost operators, and then we'll move them in between the next two operands. Rewriting this expression, we get multiplication, 3 plus 4, and then 5 plus 6. If we evaluate this, we get 7 and 11. Next, we move the remaining operator in between the newly evaluated operands, which gives us 7 times 11 equals 77. Okay, let's evaluate this one as well. So we'll start with the innermost operator, and then we'll move this between the 5 and the 3, which gives us plus 4, 5 times 3, which is 15, and then 7. Next, we take the innermost operator and move it between our newly evaluated numbers, giving us plus 4 plus 15 is 19, and then 7. And now we take our final operator and move it between 19 and 7, giving us 19 plus 7, which equals 26. So this expression up here equals 26. Now, postfix notation is basically prefix notation, just flipped. So now the operators are behind the operands rather than in front. To solve this problem, we first take the innermost operator and move it between our 4 and the 5. So we get 2, 4 plus 5 is 9, and then the multiplication. Next, we take the remaining operator and move it between the 2 and the 9. So now we get 2 times 9 equals 18, meaning this expression up here equals 18. And for this second example, we first take the innermost operator and move it between the 9 and the 6. 9 plus 6 is 15. So we get 15, 7, plus 4, plus. And now our newest innermost operator is this addition sign. So we move it in between 15 and 7. 15 plus 7 is 22, 4, and then plus. And since we're only left with one operator, we move this between the 22 and the 4, and we get 22 plus 4 equals 26, which means this expression equals 26. Okay, but why do we need postfix and prefix notation when we can just stick with infix instead? Well, it's because it's easier for computers to evaluate. Take, for example, this equation. If a computer wants to evaluate it, it'll need to worry about order of operations and a whole bunch of other complexities. However, if we rearrange this in a postfix notation, then we can directly push and pop off of the stack without needing to worry about order of operations. As you can see here, we can directly push the characters onto the stack in chronological order and also evaluate them.